Today we're going to talk about using similar right triangles. If I have a right triangle, this side is my hypotenuse, these sides are my legs, and if I were to draw a segment from the 90-degree angle to my hypotenuse in a way that it made a right angle, this would be called my altitude. The altitude divides the right triangle into 3 triangles because we have my large triangle and then 2 smaller triangles. All 3 of those triangles are similar. Because they're similar, there are some shortcuts and proportions that we can write to find missing side lengths. These 2 shortcuts are HLLAS, HLAS, and SAAS, or SAS. HLAS calls us to write the hypotenuse, which is the hypotenuse of the largest triangle, over the leg. Now, this would be the leg of the larger triangle. It could be either AB or BC. If we use AB, then our adjacent segment is AD. If we used BC as our leg, our adjacent segment would be DC. Once again, because AB is next to AD and BC is next to CD. When we use the leg, we're only going to use one leg at a time. So if I use AC right here, I'm going to use AB right here. Our other shortcut today is SAS, which is segment 1. Our segment is a part of our hypotenuse, but not the entire thing. So we're going to make segment 1 AD. We're going to make segment 2 the other part of our hypotenuse, so DC. It doesn't matter which order you do those in. And then your altitude, which is BD. So in this triangle, we're going to solve for x. Notice that x is our altitude. And we have 6 and 3, which are 2 segments. So if we're missing our altitude and we have 2 segments, we're going to use SAS, because that's segment 1 over altitude equals altitude over segment 2. Segment 1 is 6. Our altitude is x. And segment 2 is 3. So we cross multiply and solve. We get 18 is x squared. Square root both sides to solve for x. We can simplify 18 to 9 and 2, which is 3 and 3. Pull down our 2. So x equals 2 square roots of 3. Sorry, that's wrong. 3 square roots of 2. Now in this triangle, we're looking for y, which is a leg, and we're given 2 segments. We have this segment, and we also have our segment that's 5. But we can easily determine our hypotenuse as well by adding the 2 segments together. We can find that our hypotenuse is 7. So if we're looking for a leg, and we have the hypotenuse and a segment, we can use HLLAS. Hypotenuse over leg equals leg over adjacent segment. So our hypotenuse is 7. Our leg is our y. Remember, if we use one leg in our first fraction, we're going to use it in our second one as well. And then our adjacent segment is 2. Notice it's the segment that's next to the leg that we're using. So if we cross multiply and solve, we get 14 equals y squared. We're going to square root both sides. We can't reduce or simplify the square root of 14, so y is just the square root of 14. In this triangle, we're looking for z, which is our altitude, and we're given two segments, 6 and 10. Since we're looking for our altitude and we have two segments, we're going to use SAS. Segment 1 over altitude equals altitude over segment 2. So in this case, that would be 6 over z equals z over 10. Cross multiply and solve. 60 equals z squared. Square root both sides. This can be factored into 6 times 10. So we get 3 times 2, 2 times 5. I'm going to pull out a pair of 2's. So z is 2 square roots of 15. In this triangle, we have a leg. We also have a segment. And we're looking for A, which is our hypotenuse. Because we have a leg and a segment and we're looking for a hypotenuse, we're going to use HLLAS, hypotenuse over leg equals leg over adjacent segment. Our hypotenuse is A. Our leg is 10. This equals 10, because our leg again, over 5, our adjacent segment. So we get 5A equals 100. We divide by 5. A equals 20. In this triangle, we have our altitude, which is 3. We also have a segment, and we're looking for the hypotenuse. Altitude should make you think instantly of SAS, which is segment 1 over altitude equals altitude over segment 2. Our segment 1 is 5, and our altitude is 3. Now our segment 2 is not our hypotenuse. Our segment 2 is xy, so we'll just call that x. We cross multiply and solve. 5x equals 9. Divide by 5. X equals 1.8. So we know that this is 1.8. In order to figure out A, which is what we're solving for, we can add 1.8 plus 5, which gives us 6.8. And that's the entire hypotenuse. So we have 5 plus 1.8 gives us the entire thing, 6.8. This triangle calls us to solve for 3 things. We have our altitude, which is 24, and we have a segment, 32. We're going to solve for B first. We're going to look for our other segment. So we're going to use SAS. Remember, segment 1 over altitude equals altitude over segment 2. Segment 1 equals 32. Our altitude is 24. And then segment 2 is B. Cross multiply and solve. We get 32B equals 576. Divide by 32. B equals 18. Now we know that this equals 18. So now we can also quickly find that our hypotenuse equals 50. We just did 32 plus 18 equals 50. So now we have our hypotenuse and segments, and we're solving for C and A. Both of these are legs. So we're going to need to use HLLAS, which is hypotenuse over leg equals leg over adjacent segment. Our hypotenuse is 50. Our leg, will solve for C first. C over our adjacent segment. If we're solving for C, our adjacent segment is 32. So C squared equals 1600. square root both sides. C equals 40. And now we still need to solve for a, so we're going to do the same thing we just did with HLLAS. So our hypotenuse is 50 over a equals a over 18, because remember we're going to use the segment that's adjacent to a. 50 times 18 is 900, so 900 equals a squared. Square root both sides. A equals 30. So now we've solved for all three variables. And this is our last problem. So we're looking for our altitude, and we have legs and the hypotenuse. Now, with the hypotenuse and the legs, we can't find our altitude because our shortcut is HLLAS, but we can use this to find our adjacent segment. So in this case, we're going to solve for ZW, and we're going to just call that Y. So our hypotenuse is 20 over our leg, which is 16. That equals our leg over our adjacent segment, which is Y. So we get 20y equals 256. We're going to divide by 20. Y equals 12.8. If this is 12.8, we can simply do 20 minus 12.8, which gives us 7.2. And that tells us what our other segment is, because we just did the entire hypotenuse minus one of the segments gives us our other segment. So now that we have two segments, we can use SAS to find our altitude, because SAS is segment 1 over altitude equals altitude over segment 2. So our segment 1 is 12.8 over our altitude, which is simply x, equals x over our segment 2, which is 7.2. When we cross multiply, we get 92.16 equals x squared. We can square root that, and you can simply put that in your calculator. X equals 9.6.